Hi, my name is G. In the last video, we updated our Hex Nut command to use a Hex Nut icon so that in our toolbar we have the Hex Nut icon instead of the box icon. However, when we click it, we still see that we're creating a box. So let's take our first step towards actually generating something a little bit closer to the Hex Nut geometry and get rid of this box. So how can we do this? Let's take a closer look at what we're trying to achieve and think about it. So one way that we could do this is, what if we create a three-dimensional hexagon, a hexagonal prism, and then we create a three-dimensional cylinder and subtract the two? What if we cut the cylinder from the hexagonal prism? By that method, then we could achieve this hexagonal nut geometry. So let's go ahead and try that. Let's see if we can first just create a hexagonal prism. So how would we write that code? What would that code look like? So lucky for us, I have a GitHub Gist that has this snippet that'll create a three-dimensional hexagonal prism for us, because this isn't exactly easy or straightforward to do in FreeCAD, especially not for a beginner. So I'll include a link to this in the description below. And what I'm going to do is just copy this code snippet, and then I'll open up FreeCAD, and I'm going to navigate to the library package, the OSE fastener folder, go into part, go into the _ hex nut, find the hex _ nut.py file for my hex nut part class. This is where I'm going to paste in that code, and I'm going to highlight and select these import statements, cut them, and then paste over that import part statement at the top. And then I'm going to replace this part.makeBox call with the call to make hexagonal prism. For the first argument, for the minimal diameter, I'm going to pass in 10, and the second argument for the height, I'm going to pass in 4. So the first argument of 10 was for the minimal diameter, which is the flat to flat distance of the hexagon. The height is just the height of the three-dimensional shape. So let's go ahead and test this code and see if it works, and then we'll talk a little bit more about what it's doing. So I'm going to quit out of FreeCAD and reload it by typing the FreeCAD command, and select our OSE fastener workbench from the dropdown and click our button to add Hex Nut. Zoom out a little bit. We'll see here we have our three-dimensional hexagonal prism. And then if we were to take the ruler here and just quickly measure, we can see that the distance from either side, flat to flat, is about 10 millimeters, and the height is going to be 4 millimeters. So that's great. Let's talk a little bit more about the code. And I realize that a lot of this can be a little bit overwhelming at first, so at a high level, here's the general approach that we're taking. We're going to get a list of vertices that form the hexagon, so each of these edges here, we're going to get 6 vertices into a list, and then we're going to create something called a wire. And you can think of a wire as a set of edges, and an edge is made up by 2 vertices. So we have a hexagon wire, and then we take this wire and we create a face out of it. So think of a face as a two-dimensional plane, and then we're going to extrude the face in the z-axis, so up and down, by whatever our height is, which is 4 millimeters. So what we're effectively doing is we're creating a a set of vertices for a hexagon. We are making a wire out of those set of edges, creating a two-dimensional plane or face, and then extruding that up in the z direction by 4 millimeters. So this approach to creating three-dimensional objects is something that FreeCAD refers to as topological data scripting. It's kind of hierarchical in nature. And so if I just Google topological data scripting, see it's in my browser history, and I'll link to this in the video description below. But so here we kind of talk about the topology that I went over. So you have vertexes, they correspond to points. The vertexes can make up an edge, edges can make up a wire can create a two-dimensional plane or face, and you can do operations on a face like extrusion to create a three-dimensional solid, which is what we did here, creating a solid by extruding the face. You'd also want to know just the various methods that you can call on, for example, the part module that we're using here. So we've already seen make box, we're using make polygon here. And so if I want to know more, I can search for part API, and I'll include a link to this page as well. And we'll see a warning at the top, this is out of date, but from my experience it's mostly up to date. So here we see make box and the arguments, little description, make polygon. So, and we saw in the other, so part.face, you can see more information about faces here, about creating a face from a wire. Only closed wires can be valid faces. So lots more of information that we have here. Finally, another way that you can see the available methods for the part module is you can go into FreeCAD. I'm going to clear the Python console. If you don't see the Python console, go to View, Panels, make sure you have Python console checked, and we're going to import part. And then we're going to use a special function called dir or dir, pass in part and hit enter. And this is going to show us all of the available methods and attributes in the part module. And we can make this a little bit prettier by adding new lines between each of these. So if I were to create a new line character in a set of strings, call join, dot join, pass in dir part, that, and then the last thing I need to do is pass this into a call to the print function. So now I get a little bit of a prettier list of this. I can include this in the description as well, but we'll see things like face, make cylinder, make polygon, make box, and then if I wanted to see additional information on something, I could do, there's a help function. I could say help part.make box, for example. Whoops, that doesn't, you have to not have a set of parentheses here. So I see some description here. So it takes in length, width, and height, optionally a point, and I'm not exactly sure what this last dir parameter is. But yeah, sometimes the help is hit or miss, but it's there nonetheless. So yeah, in the next video we're going to take a step closer at improving this geometry by creating a cylinder and cutting a hole out of the center. Thanks for watching, and let me know if you have any questions or comments below.